Hey everyone, welcome to Electrolysis Part 3. Let's get straight into it, lots to do. Okay, here we go. So we've spoken about oxidation and reduction a lot. Let's get into what these things mean. Oxidation and reduction simply means the loss or gain of electrons. So something like, for example, chlorine, an ion that is present in, if you melt sodium chloride, table salt, if you melt it, it will turn into ions. We're otherwise call this ionizing something. So if you ionize water, it's going to break up into ions, H plus ions and OH minus ions. Okay, so chlorine, if it turns into two chlorine ions, turn into chlorine gas, and they both these ions here lose an electron each. Okay, this would be called a oxidation reaction. Okay, it's as simple as that. And we can remember this with this mnemonic over here, oil rig. So oxidation is lost, reduction is gain. So a reduction reaction would be something like sodium ion gaining an electron and forming sodium metal or solid sodium. Okay, this would be a reduction action because it's gaining an electron. So it's as simple as that. So if you look at a summary of the electrolysis of molten sodium chloride, remember the anode from this mnemonic panic is positive is anode, negative is cathode. So the positive anode, we've got chlorine happening there. So think about that that reaction that I drew in part 1 or 2, I can't remember. Positive, chlorine's negative, it is attracted to the positive and it's losing that electron. This would be a oxidation. It happens at the positive terminal called the anode. Remember the terminals or the electrodes are made out of carbon because we don't want the chlorine to react with the carbon. Okay, we want a very unreactive substance like carbon and platinum. Okay, so and then cathode, of course, this is the negative terminal and sodium is attracted to that negative terminal, and this is a reduction reaction. Simple. Okay, we are going to move on now to talk about some other examples of electrolysis, specifically talking about aqueous examples. Aqueous meaning that it's a solution that forms ions. Okay, and yes, molten sodium chloride forms ions, but when we use water, when we add water to something, we can make an aqueous solution. Okay, so for example, let's talk about sodium chloride, except that we're not going to heat it up. We're just going to add some water to create an aqueous solution. Have a look here. Okay, so I've got similar setup. I've got my battery. I've got my carbon electrodes. This would be the anode on this side because it's the positive side. Oxidation is going to occur here. Remember that that mnemonic anox, oxidation, and red cat. Okay, so we've added water. Now remember I said when water ionizes, just go to the right hand side here, when water ionizes, it turns into ions. That's what ionizes means, turning into ions. And this is a reversible reaction because if you think about it, H plus and OH minus, these are ions that have opposite charges. So they're going to be attracted to each other and they're going to form water. Okay, and then water is going to ionize back into ions, and this is going to be happening the whole time. Okay, so let's have a look at this picture. All right, so we've got now, I've added the ions into this beaker that our electrolysis is happening. Okay, I've added water and here we go. What happens? Well, same thing. Chlorine is going to be attracted to the positive terminal because chlorine is negatively charged. Same thing over here. Another chlorine atom joins up. These two then lose an electron each, and this then forms chlorine gas. Okay, so these negative charges go away and the chlorine gas then floats to the top, and there it goes, chlorine gas. Okay, what we can actually do is turn these into not ions, but we can turn this into chlorine gas. So ClCl, this is a diatomic molecule, and this whole thing, which I hope it lets me, it floats to the top like a gas. Okay, perfect. So let's leave the gas up at the top there. But what about the OH minus? Well, these are also negatively charged, so these are also attracted to the positive terminal over here, or the positive electrode. Okay, in international GCSE, we don't really need to know what happens to these OH minus molecules. Because there are more chlorine ions in solution, we're mainly going to form chlorine gas at the anode. But I will do a little section on this, on what happens to these OH minus. In fact, what we can form, I'm just going to speak about it briefly here, is we can form oxygen, if you think about it. So we've got two OH minus ions. We can actually form O2. We can form oxygen because there's enough oxygen in the ion itself. We can also form water at this point. Okay, so I just want to just briefly mention that. It's not important to study for international GCSE. It's very, I doubt they're going to ask that. Okay, so what's going to happen at the cathode? Well, we've got this H plus ion over here. Okay, this H plus ion is going to be attracted, and this sodium is also going to be attracted. Now, this is where it gets really interesting, because what is going to form at the cathode? Is it going to be hydrogen gas? Remember, we've got two of these hydrogen ions. Let's bring two of them here. We've got two ions, so we could form hydrogen gas, or we could form solid sodium. Now, we know sodium is an incredibly reactive substance. So what normally happens here, and I've written this out the bottom of this drawing, sodium is very reactive. It's difficult to add an electron to sodium. In other words, remember the electrons are coming out of this battery. Okay, here's an electron. It's coming out of this battery. Here it goes, here it goes. It's going down the electrode, and it can actually join up with either of these. But it's easier for the electron to join up over here and over here. So each of these would get an electron. It's much easier to join up to the hydrogen than the sodium. So what in fact happens is those H pluses, they lose their plus charge because they've gained an electron, and we form hydrogen gas. So sorry, this, okay, you understand that. Let's just take that to the top there. Okay, so let's just draw a little H. I hope it lets me. No, it won't. Okay, let's just give me a second. Oopsie. Okay, so you can understand that there is another. Let's just do a copy of this maybe. Okay, let's copy that. Oh, it's all going wrong here. Hydrogen over there. Okay, let's see if it'll let me draw on top of it. There we go, nicely. So there's an H2 gas molecule, diatomic molecule, forming at the cathode, at the negatively charged electrode. So this is different than molten sodium chloride. Okay, remember we are doing aqueous sodium chloride over here. So the difference is that hydrogen gas is going to be forming at the cathode, not solid sodium. And this is because sodium is very reactive and it's very difficult to add that electron. Excellent, excellent, excellent. Let's see if there's anything else we've left out. No, I think this is pretty much it. Okay, so the half reactions, what's happening? So we've got two hydrogen ions that are gaining two electrons to form hydrogen gas. Okay, we have got two chlorine ions. Remember, this is happening at the cathode and this is at the anode. Yeah, awesome. Two chlorine ions, they lose two electrons, they form chlorine gas. Okay, so what's going to happen is there's going to be a buildup of OH minus OH minus ions in this solution. So there's going to be a whole bunch of these, okay, building up in here. And as the chlorine gets lost and as the hydrogen gets lost, we have a buildup of OH minus. And this is what makes our solution, the solution that's remaining inside here, quite alkaline. Okay, so I just thought I'd mention that over here. Remember, we can write this reaction out in full. So we can say 2H plus, I'm just taking everything on the left hand side, plus 2 electrons plus 2Cl minus is going to give me H2 gas. I should be writing aqueous for the hydrogen and the chlorine ions. I'll do that in a second. Plus Cl2 gas plus 2 electrons. Okay, so the electrons are going to cancel and these two things are going to be attracted to each other. So we're going to form 2 HCl. Okay, and we are going to form, and remember this would be, HCl is going to be aqueous, and then we're going to have H2 gas plus chlorine gas. Okay, so this is basically your finished balanced equation. Is it balanced? Well, we've got 2 hydrogens, 2 chlorines. Yeah, it's balanced. Lovely, lovely. So this is aqueous. So we can look at water. This is just another way of looking at water ionizing. Okay, over here. In fact, it's not water ionizing. It's just another way of looking at this reaction in terms of the water. Don't worry too much about this. All right, let's go on to our brand new example. Okay, so I'm going to pause the video now, and if you have any questions about the above reaction, please remember them, write them down, and ask them to me in the lesson. Okay, I'm going to just take 1 minute, and then we're going to go and do the electrolysis of copper sulfate, and then we'll take another break after that, and then we're going to do one more example, which is the electrolysis of sulfuric acid. Okay, I'll see you for electrolysis of copper sulfate solution. Okay, so here is the electrolysis of copper sulfate solution. Remember, solution, another word for solution is aqueous. Okay, we've done sodium chloride in aqueous, and we've also done it in molten copper sulfate solution. We are going to do now, this is the second example of a solution or an aqueous substance. Okay, so what is copper sulfate? It's CuSO4. It's in solution, which means there's some water molecules floating around as well. Now, when we put these in solution, they ionize. In other words, they turn into ions. So the Cu dissociates and becomes Cu2+, the SO4 becomes SO42-. Hydrogens are going to be present, hydrogen ions are going to be present, and OH minuses are going to be present as well. So these things are sort of chilling in this solution. Okay, there are thousands and thousands and thousands of these things, but for demonstration purposes, I'm just going to put a few of them in here. So there we've got our ions in solution. Fantastic. Okay, we rig this up to the battery, and remember, from an exam point of view, we can write a few things. Positive, we know is the anode. We know oxidation is going to occur over here. We know that this is the cathode, and we know that reduction is going to take place on this side. We know that if this is a positively charged electrode, remember it's made out of carbon, then the negative ions are going to be attracted to the positive side. So we've got this OH ion over here that is not moving with me. Okay, so this is going to be attracted to this side, and the sulfate ion, the SO42- is also going to be attracted. Then we're going to get the copper that's going to be attracted to this side, copper 2+, and the hydrogens as well. Okay, now in terms of the electrons that we've talked about, we've got electrons that are going to be coming out of either the OH- or the SO42-. Now, this is something that we'll talk about in later chapters. How do we know which one is chosen? For now, I'm just going to tell you. Okay, so it's easier to, let's talk about the cathode first. So this is at the cathode. And this is at the anode. Okay, so at the cathode, remember the cathode is this right-hand section over here. It's easier to add electrons to copper 2+ than to H+. So what's going to happen here is at the cathode, we are going to be, electrons are going to be flying out of this battery, okay, and 2 electrons are going to join up with this copper 2+ ion. Boom. So this copper 2+ goes from being copper 2+ to being copper solid. We all know that copper solid, So this is now going to become not copper 2 plus, but it's going to become just copper. And we all know that there's millions of these copper 2 plus ions in solution. So in fact, all of them are going to be starting to be attracted to this electrode, and we're going to start forming copper. And now what color does copper look like? It's got this orange color. So you'll start to see, if you run the battery for quite a long time, you're going to start to see this orange layers start to appear on this electrode like this. And we can do a half reaction for this. So we can say copper 2 plus, it's gaining 2 electrons, gaining, remember reduction is gain from oil rig, and this is going to turn into copper solid. We could also write this like this with our state. So this is in aqueous, and this is going to form solid copper. So this is our first half reaction over here. Now what's happening at the anode? Well, which of these gets chosen? I can tell you right now that it's much easier to remove electrons from the OH minus. So what in fact is happening here again is we are going to be using 2 OH minuses. We're actually going to be forming oxygen gas. So we'll start to see oxygen gas in the form of these little bubbles start to form on this side. So yeah, you can write this in another way. In fact, what the correct way to write this would be to write 4OH. This is just in terms of balancing equations. 4OH, these are in aqueous, these form water, 2H2O plus oxygen gas plus 4 electrons. So it's actually going to pull out 4 electrons each from one of these ions, and it's actually going to take it from all 4, and 4 ions are going to form water, and it's going to form oxygen gas in the form of these bubbles. Okay, so if you think about it, if we are removing, I wonder if it will allow me to erase just the ions. Let's have a look here. Okay, so yeah, it's going to actually remove everything, which is problematic. I don't want to do that. Okay, so let's get a little summary of what's going down here. Let's just move to the right here. Okay, so come on, program. Here we go. Okay, so what's actually happening here is we're going to have 2 reactions. We're going to have copper 2 plus 2 electrons. This is, remember, this is aqueous in brackets. It's going to form copper solid. Then we're going to have 4 OH minus, which is aqueous, which is going to form 2 H2O plus the oxygen gas plus 4 electrons. This is the reduction, and this is the oxidation. Okay, so what's going to be end up left in the water? Well, if you have a look at it, what ions were left behind? Well, remember we had initially we had some H plus ions, we had some copper sulfate, not copper sulfate, we had some copper 2 plus ions, we also had OH minus ions, and we had SO42 minus. So what's going to be left behind is we're going to be left behind with a whole bunch of H plus ions, and that's going to make quite an acidic solution. All right, and the reason why it's going to make an acidic solution is because if you think about it, we are going to have, as I said, H plus ions left behind, and we're going to have SO42 minus ions. These two are attracted to each other, and what this can form is it can form H2SO4, and this is otherwise known as sulfuric acid. Okay, so this is a substance that if you allow this battery to run for long enough, you're going to form this substance. And eventually what's going to happen, because copper sulfate in general is this blue color because of these copper 2+ ions. And eventually, when all of those get used up, this solution goes from being quite a blue solution to being a clear solution. So that's something that you might also observe. And then there's just one other point, that there is another way to write this oxidation reaction. You could write it like this and sort of flip it around. 2H2O, which is liquid, forms O2 gas plus 4H plus 4 electrons. Okay, this is another way to write. You may see both of these equations in your exam. Okay, that is the electrolysis of copper sulfate. Just a few things. Don't forget that you will start observing this copper solid forming on the one electrode. Okay, cool. Let's go on to our last electrolysis, which is the electrolysis of dilute sulfuric acid, which is H2SO4. We've got this little apparatus that I'm going to explain in a second. So I'm going to jump to a new video for that. Okay, and on to the last reaction, or not reaction, but experiment on the electrolysis of dilute sulfuric acid, which is H2SO4. Okay, excellent. So what we've got here is an apparatus where we can actually measure the volumes of gases. So as soon as gas is produced, these bubbles will start to form. What's going to happen is the gases are going to be present in this section, and what's going to happen is there's going to be a different gas that gets produced at the other electrode, and the gas is going to form in this section. And what we can do then is we can actually measure the amount of gas, and this is what's really interesting about this experiment. So let's go through it. Okay, so we got H2SO4, right? We've got water. We know we have water because it's an aqueous solution. So what kind of ions can we form? We can form H+ ions. This is from the sulfuric acid. We can also form SO4 2- ions, sulfate ions, and then from the water, of course, we can also form H+ ions, and we can form OH- ions as well. So these are all going to be present in this apparatus. So we're going to have H+, we're going to have OH-. These things are going to SO4-, let's write that somewhere, SO4 2-, and we're going to have what else we got here? Let's just chuck some more H+. Okay, so what happens? Well, remember, we have got to rig this up to a battery. This is the positive terminal, so this would then be the anode. Okay, this would be the cathode. What else do we write? We write that we have oxidation happening at this side. Oxidation is loss of electrons, and then we have a reduction, this is the gaining of electrons. Now, because this is negatively charged, I just have to look at the battery, and this is positively charged. What's going to happen is the OH- ions, whoopsie, this is going to be difficult to do. I'm just going to draw them on here instead. The OH- ions are going to be attracted to this side. And just like the equation we did from the previous example, if I wrote a half reaction for the anode, it would be 4 of these OH-, 1, 2, 3, 4 of these are attracted, and what they form is, remember, these are aqueous. What they form is, it forms water. Okay, 2 water molecules, 2 H2O. H2O is in liquid form, and it also forms oxygen gas. And we need 2, because we've got 4 OH-, we need to lose, these are going to each lose an electron, or each of them are going to lose an electron, and so we need to write here 4 electrons. Okay, this is the first half reaction. Now what's happening at the cathode is we've got the SO4 2-, and we've got OH-. Now I'm talking nonsense. We have a negative terminal, so the positive, the only thing that's positive here from the ions that are dissociated is the H+. So we're going to have a whole bunch of H+ ions forming over here, and we know H+ ions we know that we just have two H plus ions, they gain 2 electrons, and we form H2 gas. Remember to put aqueous, I always forget that. Okay, H gas. Now, just from looking at the equations, the half reactions, should I say, not equations, we have to use four OH minus ions and 4 electrons to produce 1 molecule of oxygen gas. Now, if you look on the right hand side, we use 2 hydrogen ions and only 2 electrons to produce 1 molecule of hydrogen gas. So if you had to run this experiment and you had to look at the bubbles, so there's going to be bubbles forming here, bubbles, 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 and bubbles, 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 you can see that we form twice as much hydrogen gas than we do with oxygen gas. And this is from the half reaction. So it's very important to realize why this is, and it's from these half reactions. So let's just write them out one more time. So in fact, I'm just going to leave it as it is. It is because we have to use 4 electrons, 4 OH minus, to only produce 1 oxygen molecule, and on this side we only need 2. So you can actually use twice as many to form twice as much oxygen. In other words, we could do it like this. Okay, and we could make twice as much hydrogen gas, and this is what happens in this experiment. So that concludes our topic of electrolysis, everything you need to know for your exams. I know it's been long, but give them a watch, give them a couple watch, write down some questions and bring them to our lessons. Awesome, guys. Have a brilliant rest of your week.